All right, today what we're going to be talking about is functions and function notation. So let's go ahead and let's get started. So first off, some important information is a relation. That's a set of ordered pairs. So you can represent it different ways. You can do it as an ordered pair where you have your x and your y. You could do it as a table where you also have an x and a y. And if you notice, these two numbers are related here, so that's related to that. That's related to that, and that's related to that, and you can end up making ordered pairs out of it. You can also do it as a graph where this is your x, this is your y, and you can also make it as mapping. So with mapping, what you do is you have an input, which is typically on the left side. This is your x values, and then you have your output, which is on the right side, and this is your y values. So you make ordered pairs out of them by follow the arrows. So if you look at 2, you follow this arrow, it goes to 20. So we made an order pair like this. And then this 2, you follow the arrow down to 40, and it makes this ordered pair. 4 goes to 40, and then 3 goes to 30. So that's how you can make ordered pairs out of this. Now, some important information you need to know about these is you have the domain. Domain is the x value. We'll also call it the independent variable. And you have a range. Your range is your y values, and that's called the dependent variable. So all of these mean your x's, and this means your y. All right, so let's go ahead and let's do a discrete graph. We're going to identify the domain and range of the relations. So for this, you've got a couple options where if you're looking at your x's, I usually go left to right. So I'm going to look until I see, oh, yep, there's a point on -3. Then I keep going, oh, there's a point on -2. And then I keep going this direction. Oh, I've got 2 points on 1, but I'm only going to write 1. We don't need to write repeats, and then I'm going to keep going, and then I land at 4. So that's your x's and your y's, or your x's, excuse me. Now for y's, I like to go from the bottom to the top, so from the negatives to the positive, because we put this in order from least to greatest. So going up my y-axis, I see I have a point here, which is -4. Continue up, I've got a point at -2. I have a point right here on the x-axis, which is 4, or which is 0, because this is 0 on the y-axis. And then I have continue going up. I have at 3, and then I have at 5. So this is how you would label it. Or what you could do is just make ordered pairs out of all your points, and then from there list it. So you could go -3, -4. Oops, that's a little bit thicker than I wanted to write it. And then just go through, and then you would go -2, 5, and then you have 0. We don't have any on 0. Okay, and then you've got 1, -2, and 1, +3, and we have 4, 0. So another way to look at it is this way, where these are your domain, these are your range. Okay? All right. And then here's mapping. For mapping, same thing. Follow the arrow. So if I'm going to do this, this is actually easy. For domain, you just write everything that's in here. So this should be -1, 0, 1, 2, 3. If there's any repeats, only write it once. Range, you just write exactly what's here. There you go. That's easy. And you're going to try this one, and you're going to do those two. So finish those two, and then we'll keep going. All right. So for a function, every relation in which every x value has only one y value, basically your x's cannot repeat. So all x values have to be different in order for it to be a function. So relation is just any ordered pair, but a function is a specific type of relation. All right, so let's look here. and we're going to determine if these are functions. So if you notice, yes, this is a function because each x value has only one arrow coming off of it. So if you look, one arrow, one arrow, one arrow, one arrow. So the answer is yes. Now this one is no. The reason why is I've got one arrow here, but look at 3. 3 has an arrow coming off here and an arrow coming off here. So since 3 repeats, it has 2 or more arrows, this would be not a function. All right, so I want you to go through and I want you to determine if these are functions, and remember to only look at the x values. So y's could repeat for a function, but x's cannot repeat. All right, now let's talk about graphs. So for graphs, we like to use a vertical line test to see if it's a function. So you can draw a vertical line anywhere in the graph, and it hits the graph anywhere in more than one point, the relation is not a function. So basically what you're doing is you're going through. So if you look here, oh, it only hits 1. Oop, here it hits 2 times. So since it hits more than once, it's not a function. And then here, 1, 1, once, and once. So since this didn't have any repeats, it's yes. This is a function. All right, I want you to try this one using the vertical line test and determine if it's a function or not. All right, now this is new, function notation. So you can use, and you say this f of x. So if it's a f outside the parentheses, you say f of x. It does not mean f times x. So we have an equation where instead of y, we can write f of x. And instead of w, we can write f of t. So the letter inside the parentheses is the variable you're looking for. So if you notice, t here, t here. All right, so all we're going to do is rewrite it. So if you look here, we have y, and it's x. So y equals 4x. So this guy is going to go inside the parentheses, and then just say f of x equals 4x. So same thing here. We take whatever the variable is, put it inside the parentheses, and then rewrite the equation. So these are pretty easy because your variables are x's that you're looking for. So go ahead, rewrite those. All right, now to evaluate, we're going to use parentheses. So the number in the parentheses is the number you are plugging in or substituting into the equation. Okay, so if it says f of x equals 13x minus 14, it says find f of negative 2. So what that means is wherever you see x, you're going to substitute in negative 2. So if you notice, I put it here, and then 13 times negative 2, and again, substitute it in, and then go ahead, simplify it, and you're going to have f of negative 2 equals negative 40. So this is your input, this is your output. So when you write it as an ordered pair, it would be negative 2 comma negative 40. So when x is negative 2, y is negative 40, or f of x is negative 40. All right, so here, now be careful because again, we've got negative 2 for x. So wherever we see x, we're putting in negative 2 instead. Again, make sure you're using parentheses whenever you substitute it in. So we're going to get 4 minus 10 minus 1, which gives you negative 15. So f of negative 2 equals negative 15. And this would be the ordered pair. This is the notation. All right, now be very careful on this one. If you notice, there is a negative outside of x. So we're only substituting in 3 exactly where x is. So be very careful, this negative should be outside the parentheses. So you should have f of 3 equals negative parentheses 3 squared plus 5 times 3 minus 1. Go ahead, simplify it. So remember, 3 squared is 9, but then we're bringing this negative down to make it negative 9. Minus 15 minus 1, you get f of 3 equals 5. If it asks, so this is the function notation. If it asks to write it as an ordered pair, that's your ordered pair. All right, and then this one here is wherever we see -2 or x, we're plugging in -2. Now be careful because this one's to the third power. So this is really -2 times -2 times -2, which would give you -8. And then bring it down, you'll get f of -2 equals -9. And if you have to write it as an ordered pair, when x is -2, y is -9. All right, now this last one is different because it says find x if f of x equals -15. Well, remember, we said f of x is the output, so this is basically your y value. So we're going to substitute in, wherever we see f of x, we're going to substitute in -15. So here, we're going to put -15 equals -3x minus 12. We're going to add 12 to both sides. And then I get -3 equals -3x. Divide both sides by -3, and I get 1 equals x. So remember, this is basically your y. So it's telling you y equals -15, so that's why we're substituting -15 into there. All right, I want you to go through, and I want you to try those. And then we're going to do some other ones where we're going to be given the functions, 3 different functions to look at. We have f of x, we have g of x, and we have h of x. So we're going to do whatever it's telling us to do. And we'll start off pretty easy with just f of 4. So we have to use this equation. So we're going to take this whole thing, and we're going to say f of 4 equals, well, remember, 4 is your x. So wherever we see x, we're plugging in 4 instead. So when you solve that, you should get f of 4 equals 5. Okay? I'm going to skip this one, but you're going to take this one, and you're going to use that here, but wherever you see x, you're going to put 2. So it should be 2 squared plus 5 times 2 plus 7. Go ahead, solve that one. Okay, now for h of x, same thing. We're going to put a -7 wherever x is, and we get 33. So go ahead, I want you to try this one. So try both of those. And now it's going to get a little tricky because if you notice, we have f of 2 plus g of -5. So we're going to have to use this one and this one. So there's 2 different ways to do it. I'll show you one way here. One way is just to find f of 2. So we said f of 2 was 2x minus 3. So we're substituting in 2 and we're going to get 1. Then we're going to do g of -5, so wherever we see x, we're plugging in -5. And then don't forget, you're adding both of them together at the very end. So f of 2 would be 1, and then g of -5 should be 7. But we're not done because now you have to add them both together. 1 plus 7 is 8. So you can do it that way where you just put them all out, or how you could also solve it would be this way. So you could just do them separately and then at the very end combine them. So if I were to say g of 1, I substituted it in and I got g of 1 is 13. So now when I put it here, I'll say g of 1 is 13. And then here, h of 2, I substituted 2 in for x. I got h of 2 is -3. But be very careful because you're still subtracting whatever this is. So watch your signs. Those 2 negatives are going to become a plus, and you'll get 13 plus 3 equals 16, and that's your final answer. So you can do them separately and then combine at the end, or you could just make one long one and then make sure you get the right answer at the end. All right, so I want you to try these 2. And then now for this one, we're working backwards because it's telling you y equals 7 when it says f of x. So we're substituting f of x, wherever we see f of x, we're plugging in 7 instead. All right, so 7 equals 2x minus 3. And remember, we're solving for x, so you're going to add 3 to both sides. That cancels out to give you 0. So I'm left with 10 equals 2x. Divide both sides by 2. You're going to get x equals 5. All right, same thing here. Remember, think of this as like your y. So wherever you see h of x, we're substituting in 21. And you're going to do the same thing. Substitute it in. You're going to subtract 5. And then, because your lines are here, and then divide both sides by -4. That's going to cancel out to give you 1. And then 16 over -4 gives you x equals -4. All right, so go ahead and try those. And then that is your functions and function notation.